Okay, in this example, we see a trig equation, and there's a couple of things that are worth noting here. First, we can definitely say that, well, we are looking at something that is, the solutions are being asked for in the interval of 0 to 2 pi. So one full rotation of the circle and nothing more. So we don't need any adders or anything like that. Second, I noticed that we're given that the sine is equal to 5/6. Now, that's not a x coordinate or y coordinate I'm familiar with on the unit circle, so it makes my radar go up and it makes me think, this may be something other than unit circle worthy, right? And then if I look a little further, I see do not round any intermediate computations. Give your answer in radians and round your answers to the nearest hundredth. So this is saying I need an approximation. All right, so that means I'm going to use my calculator to get my answer or answers. Well, we're definitely going to need to be thinking about more than one answer here, okay? So there's a couple of things that we'll need to do here. One is we're going to get our principal solution right straight from our calculator by just taking the sine inverse or the arc sine of 5/6. And we want to make sure that our calculator is in radian mode and then see what comes out. Okay, let me do. We've got arc sine of 5 divided by 6. All right, and my calculator is saying that's 0.985. Okay, 0.985 radians. Let's see, it says round to the nearest hundredth. So I'm going to say 0.98511 just to ensure that we get the right amount of accuracy there. Okay, so this is going to be one of our solutions, but we need to keep in mind which quadrants in the circle have a positive sign. And you should be able to say that quadrant 1, oops, didn't mean to do that. Quadrant 1 has a positive sign, and also quadrant 2 has a positive sign, or a positive y value, right, on the terminal side. So what we got from our calculator is right here, this 0.98511. But we also need to get this angle right here that's in quadrant 2. All right, and that's where the use of reference angles comes in. Because this angle right here is going to be equivalent to this angle right here, congruent. And so this angle here is going to be 0.98511. But that's not the angle we're looking for, right? We're looking for this angle right here. Okay, and so we know, though, that that purple angle and that green angle are going to sum to 180 degrees, or in this case, pi radians. So I can just say that that angle measure, that second theta, theta 2, is going to equal pi minus 0.98511. And we would get that out of our handy dandy calculator. And what does that end up giving us? Minus, let's see, I've got 2.15648. And at this point I can round, right? Because I can say that my two answers are going to be 0.98. Let's see, we're rounding to the nearest hundredth, so 0.99 and 2.16. All right. You could definitely double check by taking the sign of those values, and you should get 5/6. And you'd have to know what 5/6 is in terms of a decimal approximation. But that's the way you tackle a problem like that. So let's just really quickly go back over. One, we used our inverse functions from our calculator. Two, we use what we knew about our initial statement, and we identified the additional quadrant where that could be true. Here, sign being positive. And then we used what we know about reference angles to determine that second answer. All right, hope this helps, and I'll see you next time.